This is a pretty exciting section, Calculus 2. We're going to do a method of solving differential equations called separation of variables. In our previous section we looked at direction fields, which gave us a nice picture but didn't actually give us a solution. So this little blurb here discusses separating your different variables and then integrating both sides, and then you will use your initial condition to find that unknown constant. So let's see what this is talking about. So I have y prime of t equals y squared e to the minus t. So I want to get the y's on one side and I want to get the t's on the other side. So what I'm going to have is I'm going to have y prime of t over y squared equals e to the minus t. Now what I'd like to do is integrate both sides with respect to dt, because y is a function of t. I can now rewrite y prime dt as dy over y squared equals integral of e to the minus t dt. If I integrate the left hand side, I'm going to get negative 1 over y equals, and this integrating will be negative e to the minus t plus c. Now I'd like to rewrite this so that it gives me y equals. So manipulating, moving this y over this side and dividing by this left hand and then playing with a negative, I will get y of t equals 1 over e to the minus t minus c. Alright, but I want to know what c is, and I can get that c by using the fact that y of 0 equals 1/2, which equals 1 over e to the minus 0 minus c. If you do the algebra of this, you will get that c equals negative 1. Alright, so if c equals negative 1, then y of t equals 1 over e to the minus t plus 1. And that is my particular solution to that differential equation. Now if I want to see that as a graph, there she sits. Notice that this is my y of t, and the slope of this line would then be y squared e to the minus t at any time t. And note that when t is 0, then you will get 1/2, which was what we wanted. Alright, let's go to the next one. And for our next problem, here is our differential equation, and I'm going to have 3 separate boundary conditions here, initial conditions. So I will solve my differential equation by method of separation of variables when possible, and it is possible here. So I will get e to the y times y prime of x, whoops, that's x equals sine x. I'm going to integrate both sides with respect to x dx. Then I'll rewrite this as integral of e to the y dy equals, I'm going to go ahead and say that that is minus cosine x plus c, and I'll go ahead and say that this is e to the y equals minus cosine x plus c. I'd like to know what y is, so I will use that old method of taking the natural log of both sides, and then I will get y equals the natural log of, I'll just rewrite the c minus cosine x. Now I'm going to subject this to each of these different initial conditions. So that just means for case 1, y of 0 equals 1. I will have 1 equals natural log of c minus cosine of 0, and then I'll solve for c, and I'll do that for each one of these. Okay, I just plugged in the initial condition into each one and then found each particular solution to that given initial condition. So you can see that my differential equation looks differently. I mean, pretty close, but it looks differently with a different given initial condition. All right, on to example 3. With this one, they call it an implicit solution because sometimes it's best not to write it as y equals, and it's best just to leave it in some function in terms of y because it's just prettier that way. This one I'm going to use separation of variables. It's already there. I'm going to integrate both sides. Cosine y dy equals integral sine squared t cosine t dt, and for this I'm going to let u equal sine t, and then I'm going to work it from there. Alright, I solved my integral in this case and then plugged in my initial condition, found that c is 1/2. So I'm going to write my implicit solution as sine y equals sine cubed t over 3 plus 1/2. And you can see that I could rewrite that in terms of y of t equals, but it's much prettier in this form because then I would have this thing with inverse sine attached in the front of it. So I'm just going to leave it like this, and it's pretty. So let's revisit a population differential equation. This one has to do with fruit flies, blah blah blah, and assume 50 fruit flies. They're just giving me the initial condition there, and here's my equation. So I'm going to try separation of variables. Looks like I can do that. I'll move this stuff right here over to the left hand side, so that means I'm going to have 1 over, and this is going to be messy, p times 1 minus p over 300, that's pretty disgusting, dp equals 0.1 dt. Now I'm going to integrate both sides with respect to t, and I'll write down what that looks like. Integral of 1 over p times 1 minus p over 300, and this will then be my dp equals integral of 0.1 dt. Alright, the right hand side is pretty easy. The left hand side looks like I'm going to use a method of partial fractions, so I will do that and get back with you. Alright, let's go through what I've got so far. So I did the partial fraction decomposition, and I got 1 over p. Oh, first up, I wanted to get rid of this 300 in the denominator, so I did multiply through by that just to get rid of that. Made things look better. And then I integrated both sides, and now I'm sitting here. So the next thing I'm going to do is I'm going to take and raise each side. Let E be my base for each side, so it's going to look like this. That way the left hand side, then let's do this, it's going to be this absolute value of p over 300 minus p, and then the right hand side is going to be, and I can split this up into two separate, e to the 0.1 t times e to the c. I can split that up because I add exponents when I multiply, so this is the same thing. And then the next thing, I want to get rid of these absolute values. So since this thing is always going to be positive, it's this guy that I need to worry about. So let's write down that this e of c is positive negative e of c, so that I can kind of get rid of those absolute value symbols. It makes that look prettier for me to solve it. And 300 minus p. And now I need to look at this positive, negative, e to the c, whatever it is, but let's just rewrite this because this is just some constant, so let's just write it as c because it is some constant. So we'll write it like this, and then I am going to use my initial condition, which was way back up there at the top where the population was 50 at time 0, to see what this constant is. So I'll get that done for you. Alright, now with a lot of algebra, I just went through and found what P of t was, and here's what we get. Alright, and that's it for this section. Have fun with it, and if you have any trouble, email me.